141 linked list cycle, and it's an easy legal question. So giving head, the head of a linked list to determine if the linked list has cycle in it. There's a cycle in the linked list if there's some node in the list that can be reached again by continuously following the next pointer. Initially, POS is used to denote the index to the node that tail's next pointer is connected to. Note that POS is not passed as a parameter. Then return true if there's a cycle in the linked list, otherwise return false. And in this example, they give you a linked list like this, and the POS is connected to list 1. There's a cycle in the linked list where tail connects to the list, the first node, basically to here. So there's a cycle in it. So you want to return true in this case. And then the next one is the POS is connected to the node 0. And you can see, obviously, there's a cycle in it. So you want to return true, right? And the POS is -1. -1 does not exist. And you want to return false in this case. Basically, there's no cycle. There's some constraints here. And you can see that in the last 6 months, still got asked by a few different companies on this question. So let's see how we can solve this question. There are 2 different ways that you can do it. One is I'm gonna use our hash set. So I'm gonna go through every single node, right, and put every single node into this hash set. And if I see this when I'm going along this list to the end of the list, if I'm see a duplicate in the hash set in the data structure, because hash set does not allow duplicate. So in that case, you will be able to detect that if you see the same number like 2 twice, then you know there's a cycle in there. That's basically how you can do it. And let me show you how to do that in code. So you want to rule out edge cases if not head, and you want to return false, basically empty. Of course, it's false, then there's no cycle in it. And if so I'm gonna do a hash set, and basically set put scene equals to set, and then this is a set here. I'm calling the set as scene. So while head exists, right, I'm gonna, if head in scene, if the head is already inside of the hash set, the node that I'm going through, then you want to return true because there's a cycle in there. And otherwise, I'm gonna add this head into this set. For every single node that I visited, I want to add it to the hash set. So next time I know that I have visited, just showing that I visited this node already. And then I'm gonna continue head equals to head.next. I'm gonna continue to go through the entire list while head until the head does not exist anymore. I'm gonna go through this, right? Basically add every single one of them. If I go through the entire list here, I still don't find any there's no duplicate, there's nothing is duplicate, and I get out of the list, then I want to return false. Basically, there's no cycle in there. Yep. So this is the hash set method, and there's another algorithm. It's basically Floyd's algorithm where you can detect the cycle, and you would not know how to do this unless you know this algorithm. Basically, how you do is that you want to have a slow pointer, and you want to have a faster pointer, and the slow pointer move 1, faster point move 2. It's kind of similar to how you find the middle point of a linked list. And when you go through, when the slow and the fast continue to move, right? Slow and the fast eventually is going to be able to meet each other at some point. They have to be able to meet. If they are able to meet, that means that there is a cycle in there. If they're not able to meet, then that means that there's simply no cycle, because if there's no cycle in there, when the fast move to the end of the list, because fast move 2 step and the slow move 1 step, slow supposed to be in the, when fast is at the end of the list, the slow supposed to be in the middle of the list, right? So they would never be able to meet each other. And the only situation there they are able to meet, there's a cycle in there. And I'll show you how to do this in code also. And I keep this part because the edge cases is the same. So I'm gonna put slow and fast. I'm gonna set 2 pointer, and both of them start from the head node, and I'm gonna say while fast. It's kind of same code as find the half of the linked list, and while fast and a fast on next. What I'm gonna do is I'm gonna move slow to slow down next. So basically slow moves 1, and I'm gonna move faster to, and a faster to faster down next. That's what I meant. When you move slow, they all at the beginning of the list at 3, right? And when you move slow to 2, and a fast is already moved to 0, if that makes sense. So you just move 1 and you just move 2. And then the next step, 2, the slow will move to 0, and then the fast will move from 0 to -4, and then go back to 2, right? And then the next time slow will move to 0, -4, and then the fast will move 2 step, 1, 2. So slow and fast will meet at -4 here. So then if slow is equal to fast at some point, then I'm gonna return true in this case, because while I go through this list, right, they are able to meet each other. Like I mentioned, that means there's a cycle in there. I want to return true. Otherwise, if I'm not able to find anything at all, while I get out of the while loop, I'm still not able to find anything, I'm gonna return false in this case. So that's how you find that's how you detect the cycle for this by using the slow and a faster pointer. And let's see. Yep. So if you think this is helpful, please like my video, give me a thumbs up, and subscribe to my channel. And I will see you soon with more Leetcode questions. Okay, bye-bye.